Very good morning. So today we are discussing about soil mechanics, some basics of soil mechanics. The soil mechanics topic is very important in engineering point of view because of if you do any engineering projects, it may be dam, tunnel, and etc. Right? So everything that should be lying on the surface of the earth. So first we have to understand the how the soils are behaves, how the soils are behavior by soil. Soil is nothing but if you take a particular hard rocks, right, which means the solid rocks. These solid rocks are converted to the small grains, right? Converted to the small grains in various by the various process. It may be weathering, right? If you take a weathering, so number of weatherings are there: physical weathering, chemical weathering, and organic weathering, and steroidal weathering. So number of weatherings are there. So the end product of weathering is the soil, right? So here the soil is suppose we are applying the force, how it is a behavior, right? That is we call it as soil mechanics. Okay. So now I'm going to classify the soil in two ways based on the water table, right? So this is a subsurface, this is a water table. So water table, right? Above the water table, some soils are present, right? Some soils are present. Below the water table, some soils are present. Okay. So here the soil is uh, solids are there, which means solid soil plus water plus air. Okay, so here the soil plus water is there. So this zone we generally call it as saturated zone. This zone is we call it as unsaturated zone. So unsaturated zone or soil, unsaturated soil. This one is saturated soil. Saturation is nothing but, so if you take a particular soil, right? So if you, these are the grains, soil grains. In this grain, okay. So number of gaps are there. In between the grains, some gaps are there, right? The gaps, it may be filled with the air. Sometimes it is filled with the water. Okay, suppose these gaps are 100% fully filled with the water, we call it as saturated soil. So we can check one by one. Now you can understand. You can see this is a solid rock. The solid rock converted to the soil. Soil. So before that, suppose these are the grains, right? I'm going to magnify the soil. So these are the grains are there. In between the grains, some voids are there. So here there is no water, which means that type of soil we generally call it as dry soil. We can take a if you in laboratory method, we can take a soil, we can put it in the oven, right? So the all the moisture content that should be evaporated. We can get the dry soil. Otherwise, naturally we can naturally we can evaporate the water from that particular soil. We can get the dry soil. Dry soil is nothing but there is no moisture content within the soil, right? Only the grains, the solid grains are there, and water. Sorry, that air, that the air gap, the voids are present. That is, we call it as dry soil. So dry soil, which is consist with the solid grains, which means the solid means nothing else. That's the grains, solids, and in between the solids, the air pockets are there. That is means voids are present. So voids and the solid consist of soil. We call it as dry soil. There is no water over there. Okay, it's a dry soil. So coming to the bulk soil. Coming to the bulk soil, what happened? So these are the grains. So I'm already told you in between the grain some air pockets are there, which means the voids are there. Voids. So the periphery of the grains, it is what happened? Some partially water is stick on the periphery of the grains, right? So everywhere. So which means here in such a case, so solids are there, solids plus voids plus water. That type of soil we generally call it as bulk soil. Bulk soil. Okay, now we can understand. Now we can understand. The dry soil is nothing but so grains and voids are there. There is no water over there. So coming to the what is that? Bulk soil, the voids and the solids, and also the water also present. That is called as bulk soil. Okay. So coming to the another type is there. Another type of soil is saturated soil. The same grains are there. In this grain, what happened? These grains, the voids are there. The voids are completely filled with the water. Completely filled with the water. So in such a case, this type of called as there is no air voids. There is no voids are there. There is no voids. So all the voids are filled with the water. So the type of soil we call it as saturated soil. Okay, these are the three main type of soils. Okay. So first one is a dry soil. There is no, the solids are there, solid grains are there. In between the grains only air pockets are there, which means the voids are present. The second one is voids are present, solids present, and also the water also stick on the periphery of the grains. So that is called as bulk soil. Third one is the saturated soil. So the in between the grains, right? The voids are 100% filled with the water. That is called as saturated soil. Okay, now you can understand what are the main three difference. So here I'm going to, if you take here, first one is the dry soil, another one is bulk soil, and saturated soil. Okay, so three cases are there. In three cases, suppose these are the some glosses are there, right? In that particular glosses, I am going to take intact rock. Intact rock. This is a solid rock, right? These solid rocks are, suppose it is converted to the soil. So the solid rocks are converted to the soil. What happened? These solid rocks are occupy this area. Occupy this area. So like this. Occupy this area. So the grains are there and also voids are present. So grains and voids. So instead of grains, we have to usually we call it as solids. So solids are there and voids are present in the case of dry soil. So I am going to make here some another diagram. You can see in dry soil condition, solid present and voids present. Am I correct? Okay. So this is, we call it as total volume. Okay. Here this is, we call it as volume of voids. Volume of voids. This area we call it as volume of solids. Now we can understand. So in dry soil condition, so only two cases are there. One is a voids, that soils are filled with the voids and solid. So the totally we call it as total volume. So solids, volume of solids, and voids, volume of voids. VS. Okay. V means nothing else, it's a total volume. So first case. So coming to the bulk soil, we know that the bulk soil covered with the water. So the solid is there and water is there and also air also there. So there is no changes of volume. So V. So here solids, here water, this one is air or voids. Okay, but this fully we call it as volume of voids. This alone we call it as volume of air. Okay, so this one is volume of water, this area. This area we call it as volume of water. Okay, this one is volume of solids. There is no difference. So here the volume of voids are including with the volume of air and water. Volume of air and water. VV it is consists with the volume of air and volume of water. So there is no difference in the solids. VS is a there is no issues. So here the total volume of total volume. So coming to the saturated soil. So here only the water present, here solids present. So the volume of voids, here volume of water, here volume of solids. This one is volume. Now you can understand what is the three differences. In first cases, voids and solids are present. So volume of voids are equal to the volume of airs, volume of solids. Here the voids are present, the water also present, the solids are present. See, totally the voids and the water um, uh, it is consists with the volume of voids. We taken as a volume of voids. So third cases only water and the solids are present. So the water volume of voids equal to the volume of water. Okay. Void ratio. The void ratio is nothing but um, volume of voids divided by volume of solids. The void ratio is equal to VV by VS. VV by VS is nothing but VV is voids or volume of voids, volume of solids. Okay, right? We're coming to the porosity. Coming to the porosity is nothing but N is equal to volume of voids divided by volume of total volume. We generally call it as porosity. Then we have what is the relationship between the void ratio and the porosity. Now we have to check it out. Okay, so if you take a VV by VV, in porosity is always in percentage. Okay, so the porosity is VV by V. So volume of voids, volume. So here the volume of voids divided by volume is nothing but volume of voids plus volume of solids. Okay, I divided by volume of solids means so VV divided by VS by VV by VS plus VS by VS. Okay, so it's going to be right. So finally, so VV by VS we know that is nothing but the void ratio. Void ratio is nothing but VV by VS. So that velocity is equal to N is equal to E by 1 plus E. So what is meant by void ratio means E is equal to what is that? E is equal to N into N by 1 minus N. So this is the relation between the porosity and the void ratio. That is a most important one, right? The void ratio we know that only the volume of voids and solids are present. The ratio of volume of voids and volume of solids. So the porosity is nothing but the porosity always in it is percentage, right? So here the volume of voids divided by volume of total volume. So okay, then N is equal to E by 1 plus E. That is we call it as in porosity percentage, right? So here Y ratio is E is equal to N by 1 minus N. Okay, that is the relation between the Y ratio and porosity. Okay, so thank you.